So last 3 days we are discussing about a different statistical procedure. Under this, we discussing start the first day we discussing about descriptive statistics. Second day we're discussing the t-test, and yesterday we discussing Manova Mankova up to the correlation identity. And now I'm focusing on regression analysis, and particularly I'm talking about the simple linear as well as the multiple linear. Then after this, I'm gradually move to the factor analysis, and some of the Anisha is asking the one more request also. So I'm just going to give some insight about how to do the reliability analysis very fastly. And there is one more things also there. Participant asking the group that I mean the chat box. So in the flyer we are not highlighting a confirmative. Don't worry, I'm going to highlight the confirmative factor analysis row in this. But I need your um, what is that cooperation also. Because if you ask a lot of questions, I'm not able to complete everything. You can ask the question in the chat box, and pal, if you want to give some insight, you can do it. Otherwise, it will be maybe focus on the different areas. So we have only maximums on one because I'm going to be finished 8:15 after the display valedictory. So we have time for 1 hour 45 minutes. So before that, before the validity, I'm going to cover everything. I request all to cooperate with us. Yes, now we are talking about regressions. These are the things I will give later. But you must know the difference between the regression as well as the correlation. So for this, I'm just using this the slide. In the case of correlation regression, the basic difference among these two or between these two, the correlation is talking about strength as well as the directions. Strength is represent the magnitude, and the direction represents the symbol like minus or the plus symbol. Minus represents the negative correlation, plus represents the positive correlations. But the main things in the case of regression, what way the correlations may differ from the regressions. For example, you can see the slide, you can understood. The relationship no is going to find, you are going to find this mode only like x tends to y. You can see X and Y is interchangeable in the case of regression analysis. X and Y is interchangeable in the case of regression analysis. So, for example, you are finding Rxy is equal to Ryx. Is it correct or not? Anyone tell me? When you do this relationship, when you like to do the correlation of X and Y is equal to correlation of Yx. Is it equal or not? Anyone respond? When you like to do the correlation with the two variables, you would like to check with this X is the first variable, Y is the second variable. Instead of keeping the Y is the first variable, X is the second variable, whether the values to be same or not.
Same.
Same.
Same. Yes, this is the way the correlation may differ from the regression. So the interchange property is possible in the case of correlation, right? X tends to Y or Y tends to Y. Y tends to X. So therefore, the relationship you can find from this. But in the case of regression, so we have the DV though, right? We cannot check with, suppose I'm checking with the DV to IV or IV to DV, the scores are same. I'm going to check this effect of IV to DV. I'm checking the effect of IV, independent variable to dependent variable. Similarly, I like to check the dependent variable, how it's affecting the independent variable. Whether the scores are same, the scores may be same. No.
No, sir.
So
No.
here talking about effect. Therefore, the interchange property is not possible in the case of regression analysis. And the next one, it's moved together. You know that X increasing, Y also increase, that is called positive correlation. If X is increasing, Y is decreasing, it's called negative correlation. These are things you know that. So it will be movement maybe together like up or down. So this way is going. But here the regression the effect is going to check about the predictions. Okay. Changeable. And in the case of correlation, the data represented in a single point. Okay, in a single point, because you can see this here. Normally, we are checking as part of the correlation. We are checking this whether it's a correlation is positive or negative. You can see the diagram. It is talking about positive correlation. And but in the case of regression, we are going to find out the equation, the straight line equation we are going to find. So the regressions is going to help to prepare, create a regression equation. So correlation, we cannot prepare any kind of equation. Correlation is talking about only the strength and the strength as well as the directions. But in the case of regression, we can find out the two things. One is the cause and effect. The second one, we are going to find the regression equations. That may call us a regression equation. This is the way that correlation may be different from the regression. Any doubts about this? Any doubt? You must be familiar because correlation, you can change this x tends to y, y tends to x, no problem. But in the case before doing the analysis, you cannot change the portion. This idea. I'm just going back so you can see this JASP interface.
So sometime your voice
Just
is
clicking
stuck.
this and just randomly selecting one data and just randomly selecting.
Your voice is breaking, sir.
It's okay.
Your network is a little bit weak, it seems.
Okay, 1 minute. Just and just yeah. Sorry, there is a small network issue, so I just came to my phone. Here, there's a small network. It's okay now. It's visible. 1 minute, I'm just saying.
No, screen sharing yet to come. Yeah, done.
It's coming, right? I think it's small delays there. Okay. Still is not finding, right? Yes, I'm just moving to JASP. I'm opening some JASP software. One thing, I'm just changing my. I'm trying my network hotspot. 2 minutes. It's okay. Hello. Now it's okay, right? Network is okay now? Okay.
Yes, good.
Sorry, I just connected with my okay. Now we can see this. Just I'm going to do a small demonstration. How the interface while doing this correlation analysis as well as the regression analysis. First, I'm just randomly opening one data set. So randomly, okay. So the data we use this data set, no. So the desktop itself is there. I'm just going to the browse and opening a desktop base. There is an survey data. Right now, you can see this when you do for a regression correlation. Click the correlation. Whether you can find out any kind of independent variable, dependent variable differences. It asks me only the variables. What is the title they provide? Only the variables, right? But when you go to the regression, you can see this. When you go to the linear regressions, what are you finding this?
Dependent variable.
No, what is
Dependent variable. Why in the regression correlation they're not highlighting that one? It's an independent variable, dependent variable.
Because
that is not
does not
needed.
changes.
That is not needed. That is not be needed in the case of correlation because going to check the two variable relationship only. We are going to identify the commonness between the two variables. Therefore, in the case of correlation, there is no worry about which is an independent variable, dependent variable. But when you like to do the regressions, the first thing you must be decide what is your dependent variable. And one more condition that for doing the regressions, any idea how many dependent variables possible to do a regression analysis? Number of dependent variable.
1.
To doing the regression analysis. Yes. Now you can see what is the heading. What is the heading? Dependent variable. Even some people, when I ask, some people are asking to me, sir, I have two dependent variable. Can I do regression analysis? It's not possible. If you want to do this, do separately for regression analysis one variable, one dependent variable. Then second time you can do the another variable. You cannot do the attached stretch to dependent variable basis. In the case of linear regression, not possible. And this is a basic assumption. Only one dependent variable. What is the format? What is the format of dependent variable?
Continuous.
It is a continuous, right? Here the covariate is nothing but your independent variable. We need to keep its covariates here, right? So in this case, is the covariate, and particularly the covariate also. What is the format? It will be a continuous, like your independent variable. If you go with a simple linear, you have only one. Listen, the difference between simple linear and multiple linear. Simple linear means only one independent variable, only one dependent variable. Multiple linear means you have two or more independent variable, only one dependent variable. So that's the reason the covariates is a plural. Why the covariates plural? Because the same path we can use it for multiple linear as well as simple linear. That's the reason they made like this, right? So we can go to the slides now. Yeah, I'm just skipping this and directly moving to this particular slide. And you know that in the case of regression, we have a lot of regression is there. One is for simple linear, multiple linear, logistic regressions, ordinal regression, multinomial regression, discriminant analysis. Plenty of regressions people are doing there. Please mute, please mute. Right, now we can see this case. The simple linear, I'm just going to give this insights about the difference among the three. Simple linear, why I put the variables in the sense, because this headings meant for the all kind of regression, and that's the reason I just put bracket in yes. But dependent variable, I not put any yes. Why? Basic
Yes, only
assumption
one
that
is
you are,
possible.
yeah, dependent variable for any regression analysis, your dependent variable only one only. Your dependent variable should be only one. Now, in the case simple linear, your independent variable, I'm talking about independent variable, should be only one, and the variable should be interval ratio. Therefore, what is the meaning? It should be a continuous. It should be a continuous. But your dependent variable, it should be a continuous only. It should be only one. This is a basic assumption you must be familiar. And when you go to multiple regression, at least you have minimum two independent variables needed. But out of two or three independent variable, you have the flexibility that, for example, you have three variables. Two variables are continuous, one variables are ordinal. No problem, you can go with this. There is no need that all the variable might be a continuous. At least out of four, you have the three is continuous, one is ordinal, no problem, no issues. Okay, that is not an issue. And I use the term dichotomous, but we can use the what is that ordinal, anything we can use it. And the dependent variable should be a continuous. Right, logistic regression. So normally the education sector we are not using. Sometimes business sector they're using it. The logistic regressions, you have minimum two independent variable. This also might be in a continuous or in the case of categorical. Is both is possible, but dependent variable it should be dichotomous. What is the dichotomous? What is meant by dichotomous? Any idea?
Is kind of yes or no type of the questions.
It is only it is a categorical data. It's like
nominal.
Two category. It's a nominal, only two category only. Yes or no, pass or fail. That kind of divisions might be there. Only two. Die means two. The variable you can able to divide into two factors only. So therefore, the basic assumption that your dependent variables dichotomous only you can able to do the logistic regression. Suppose your dependent variables continuous, which one you have to do?
Simple
you can go
linear,
with only a simple linear or a
linear.
multiple linear. Yeah. Other one is called ordinal regression. So ordinal, automatically your dependent variable should be ordinal. So that is called ordinal. Ordinal means what? Ranking. Okay, rank basis. Okay. Then independent variable should be nominal diagram. Therefore, what is the meaning? Both the variables are both independent variable, dependent variables are categorical in this case. Please kindly note this. Multinomial regression. Once again, multinomial. Okay, multinomial. Therefore, what is my dependent variable? Nominal. And minimum only one is needed. It may be continuous or categorical in the case of independent variable. One plus minimum one is needed. And discriminant analysis also, it will be nominal. We are going to divide into different category. Nominal, once again, it's a nominal. And your independent variable should be a continuous. These are the different types of that, but we are going to focusing on these two things only. Simple linear and multiple linear. Okay. So hope you are getting the different types of regression analysis. And I'm going to avoid some of the basic things, but I'm focusing only the main slides which is needed only. The slide also I shared, if you want, you can take it. Yeah. In the case of linear regressions, we are called the independent variables as a predictor. Listen, the independent variables called predictor. So that's the reason we are telling this, how much the independent variables predict the dependent variable. It is called predictor. And the multiple linear, we have multiple predictors. Only the simple linear as well as the multiple linear difference is that only one predictor, that is called one independent variable. multiple linear, we have the multiple independent variable. So it's going to be, this is cost, which is a cost variable, anyone? How many cost variables here? Cost means what? Cost and effect. In the experiment where we are talking cost and effect. Cost and independent variable.
One.
So
Effect is a
independent
dependent variable.
variable influence to the dependent variables.
Dependent variable, right? In this case, effect is a y.
One.
So in this case, these are the
Cost.
predictors, right? Right. Now you can see this is called regression equation. This is a regression equation. Normally we are writing this. If you want, I can zoom this also. So hope you are seeing this. I hope you are seeing this screen. Now you can see this. In the case of simple linear, we have the equation. Y is the predicted output. What is the predicted output? It is our dependent variable. And the B0, beta, normally the beta call is in coefficients. And X is then our independent variable. So B1 X, like the coefficient X, B1, beta 1 is in coefficient of X. And plus error, like everything is a residual error, might be that is an error. This is a regression equation. Normally we can call Y is equal to A plus BX. A plus, like this, the people are writing the normal formula. If it only one variable, it's okay, one independent variable. If more than that, you can see this, more than that, Y is equal to, you can see the regression equation in this case. Y is equal to, Y is a dependent variable. Here, X1 is independent, X2 is independent, up to the Xn is independent. And everywhere B0 is in constant value, plus B1 X1, plus B2 X2, plus B3 X3, and so on, Bn Xn. So up to the number of variables. So this way we can write the regression equation. And one thing you must be know that, sir, you are talking about regression, but what is the meaning of this constant value? What is the meaning of the constant value? So for this, I'm using this image. You can see this. Actually, these are the data. One data. I'm just writing this again. 3, 4, 5, 6. Right. So there is 6 data. I'm just giving this example with the 6 data. The scores are scattered here and there. And instead of taking the entire things, I'm taking as a one straight line. Actually, we are going to find out this equation, this straight line equation only. The straight line equation, you know, the y equals a plus bx. But the problem, when you take a straight line, other than the data, there is a gap between, for example, for this line to first data, small distance, this is one error. And second data to this one is another error. Third data to this line is a third error. This is another error. This is another error. And this is another error. There's how many errors might be there from the straight line to the original data? There will be 6 errors.
6 errors.
If that's called residual error. If you're adding the 6 errors, it is equal to 0 normally. If you're adding all the 6 errors, because sometimes it will be minus, this is plus. If you're adding all together, the summation of errors might be 0. That is the way we need to check. Okay. That is the meaning of the straight line. Okay, we are going to find only the linear. Linear means a straight line. Once again, the linear means straight line. In this case, the epsilon is nothing but this one. Right. Now we can know this, what is called B, like constant. The constant, for example, if X is increasing, I'm just writing X, but Y started from this point only. So Y, the score started from this. Therefore, this particular score might be a constant. This is called intercept. This one is really intercept, right? This particular place might be a intercept because that Y started from this portion onwards only. Therefore, this particular number is called a constant value plus your beta. The X is 1 means 1 times of B1. Your 2 means 1 times 2 times of B. Like this is called coefficient of X. So when you go with the Y equation, we have this formula that Y equal to beta naught plus B1x. I am using the beta 1x plus epsilon. Normally the equation they are not using, but we are using epsilon perfect, always with perfect. So this is called regression equation. The same thing I'm writing without error. Y is equal to B1 is called intercept. So you can see this intercept, in the case of regression, I'm just showing this intercept. And there is an B1 is called slope. Y is called B1. I'm just showing this example. So that according to this slope B1, I mean, this is a slope. No, there are straight line equation. The straight line, the slope, it is called coefficient of X. So this is a way the equation forming as part of the regression equations. Hope you understand this meaning of the regression equation. Y is equal to, I'm writing this A plus BX. A is a constant value, it's called intercept. B is in coefficient of X, right? That is B is nothing but the slope of the straight line, right? Any doubts? Suppose if you have the second one, then C X2 and D X3, like this may be extending. So based on the number of independent variables. So this is the way linear regression, sorry, this multiple regression may be happen. So this we already know that independent variable 1, dependent variable 1 for simple regressions. The independent variable 2 plus and dependent variable only 1, you can go with multiple regression. The basic assumption is to be continuous. Both should be continuous in this case. Both should be continuous. At least one variable should be continuous in this case. They can say independent variable. And these are the assumptions we need to cross check before doing this. The first one, the two variables should be measured at continuous. What is the two variable? Independent variable, two variable. And talking about the simple linear, both the variables should be continuous. Then only we can go with the Pearson. Then only we can do with the linear regressions, right? Linear, particularly simple linear, multiple linear. Linear relationship between the two variables. No significant outliers. We have some assumptions. We already know that there is called box plan. Through this, we can find these outliers. And the independence of our observation, we need to find from the Durbin-Watson. I will tell this how to find the Durbin-Watson. This score, it should be plus or minus 2.5 above should be needed. Or some books, they put plus or minus 3.9. So within the region, the Durbin-Watson, it's in the independence of observation. So, and we need to check this data sets of show homoscedasticity. This is, we are using some kind of tip score, tolerance score like this, some of scores we are using. I'm just highlighting the scores also. This score is talking about homoscedasticity, multilinearity is talking about this. The residual of the regression lines are approximately normally distributed, so it should be normally distributed. Then only it's possible for. Then now the question for this: if you normally distributed, we are doing a linear regression or a multiple regression. Therefore, multiple regression is a parametric and non-parametric. Parametric and non-parametric.
Parametric.
It's a parametric. Yeah, now you can see this logist regression. So now you can see this table. You know the table. What is about logist regressions? What about logist regressions?
Logistic regression is a non-parametric, sir.
Why? You can easily
Because
find that. What is the dependent variable?
A
Dependent
categorical
variable
nature, sir.
is a categorical. Therefore, ordinal regression, it is in category.
Categorical.
Multinomial, category.
It is also
Discriminant.
categorical.
Therefore, other than the simple linear and multiple linear, it may be come to the
Parametric, sir.
non-parametric. Non-parametric. Hope you are good. It's called non-parametric, right? So hope you are getting this. And just moving, these are the outliers and just, yeah, this is the formula. Yeah, please, if possible, kindly take a screenshot. We are going to find out the outlier. It's for standard residual, but the SPS we get it. So we can see whether it's possible to find it from here also. That's called standard residual. The SPS we are getting this. The score not be exceed plus or minus 329. Independence observation, as I already mentioned, the Durbin-Watson, it will be plus or minus 3. Some textbook put plus or minus 2.5 only. So, but we can go with this up to the 3. All right. So minus 1 to minus plus 3, we can adopt it. And tolerance score is talking about multicollinearity. Actually, multicollinearity can go with anyone. Tolerance or the VFA score. The tolerance score should be greater than 0.19. It will be greater than that. VFA scores, it will be is point. This is talking about point. This should be greater than. It should be greater. VFA score should be greater than 0. Sorry, it's 0.10. It should be 10. It's not point. So VFA score should be more than 10. The same thing I'm just highlighting here in my slide. This also, if possible, kindly take a screenshot. Some of the thumb rule also I'm highlighted with proper citations. And this is the recommendation also. I'm just showing this. The sample size, it should be, because sometimes you have the doubt that's how much sample size is needed while doing a regression analysis. I just giving this idea. At least you can go with this more than 20 for each predictor. What is my predictor? What is my predictor? What is my predictor?
Independent variable.
Independent. Suppose I have 5 independent variables. Therefore, minimum sample, how much is needed?
100.
Minimum 100 is needed. Okay, please. More than is fine. At minimum is needed. That's why sample size need to be cross-checked, right? Suppose I have only 2 independent variables. Then minimum how much needed?
40.
40. This is said by the higher et al. These are the basic assumption you need to cross-check. The outlier, so as already is plus or minus 3, and Durbin-Watson is talking about no correlation between the residual. He's talking about the residual error, the error correlation is there. So Durbin-Watson, it's talking about the plus 1. In other things, they're talking about 1, 2, plus 3, but some textbook, according to the field, it is 1.5 to 2.5. Multicollinearity is talking, we are finding from the VAF 10, and tolerance is to be a greater than 0.10, right? VAFI score, it should be less than, sorry, it should be less than 10. Sorry, it will be less than 10. Please, I told wrongly. Less than 10. This is set by the higher rate of. And homoscedasticity, there is an pressure Bayesian test. It is not possible in the case of JASP. It's not there since I checked with this. And the normality, you know that the normality we are going to check with this different way. One is called number basis, other one is called graphical basis, other one is called statistical. So you can use any one. So these are the assumption you must be check before doing it. These are recommendation score. So the assumption also I listed this. Right. The same thing. And one more thing, you have in going with in the case of this regression analysis, we are getting stepwise analysis, the entire analysis, as well as the forward analysis and backward elimination analysis, like this 4 kind of analysis that I am going to highlight one by one while doing this analysis. Now, I request all to open a JASP now. Open a empty JASP, right? Now we are going to open a new file. So we already having a data set. I already uploaded. Go to the browse, open your data set, the data set which I given earlier, and today also I shared this link. So I request all to open the data set. In the data set, there is a regression as a one data set is there. Okay, so I'm just going my path, JAS workshop, and yeah, so there is a data set. Under the data set, there is called regression data, serial number 8. I request all to select the regression data, serial number 8, and click open. Click open. All right. So those are open, you can type O in the chat box. Those are open this database, please kindly open the chat box.
Could you show the slide again? I want to take screenshot.
Yeah, this one, right? Yeah.
Okay, sir.
Yes. Okay, fine. So I request all to open this data set. Those are open, you can type in the chat box O, the letter O. Yes, fine. Hope you are open. Now, can you highlight a number of variables available in this? I'm talking about number of continuous variables. Number of continuous variables.
6.
Number of continuous variables.
5 plus 1.
Continuous
5,
variables.
sir. 5, sir.
5. Okay, 5. So achievement, study habits, attitude, motivation, and such. Now you can. I'm just giving a small 2 minutes time for you. Kindly look out to the find out. Kindly read this variable name and kindly find which may be independent variable, which may be dependent variable out of this. We have the 5 continuous variable. Out of 5 variable, we need to keep one is a dependent variable. So what may be dependent variable in this case? Anyone?
Achievement.
Is a
Achievement.
dependent
Of
variable,
course.
sir.
Listen, achievement is an dependent variable. Study habits, attitude, motivation, stress is a dependent variable. Therefore, number of dependent variable. So number of dependent variable 1, number of independent variable
4.
4, right? 4.
5.
Then which case for this case which regression is possible?
Multiple regression.
Multiple regression. Suppose along with this, you can take gender also, because gender also might create the effect, right? Suppose I'm taking study habits, attitude, motivation, stress along with the gender. How is going to predict on achievement? What kind of studies is possible?
Multiple linear regressions.
That is also multiple linear. Okay, so don't worry about the gender is in nominal. Some cases, in the case of simple linear only, your both variables should be continuous. But in the case of multiple linear, at least 1 or 2, there is a possible that it may be a category also, no problem, right? That's not an issue. Now you can see this case and go to the regression analysis. So I'm just highlighting the path, go to the regression. Under the regression, which one we can go?
Classical.
Linear
regression.
Linear regression. Click the linear regressions. Number of dependent variable. Number of dependent variable.
1, sir.
1.
Achievement.
So which may be dependent variable?
Achievement, sir.
Achievement. And just click in this achievement, right? Click the achievement, right? Now, when you go to the method, you can see this method. We have the enter method, backward method, forward method, stepwise. Right? For the simple linear, go with only the enter method only. Multiple linear only, we need a backward, forward, stepwise. Right? But simple linear, go with only the enter. I'm taking now only one independent variable now for doing the analysis. I'm taking only the state habits. So number of dependent variables. So independent variable now. How many independent variable I'm using now?
One.
Only one,
One.
sir.
Only one. Only one. Listen, I'm taking only one only. Now you can see this. I'm just showing this. We have three tables. Even the SPS also we have three tables. One is called model summary. Other one is called ANOVA table. The third one is the coefficients. Right? I'm just starting with this one. What is this? We need to cross check whether our assumptions are satisfied. Right? We need to check the assumptions. Go to the method specification. Go to the method. Go to the statistics. Go to the statistics. Go to the statistics. Can you find the Darwin-Watson? Darwin-Watson. What is the purpose of Darwin-Watson? What is the purpose we are using Darwin-Watson?
So that is the auto correlation, sir.
Yeah, so I'm showing this Darwin-Watson. So Darwin-Watsons we are using for no correlation between the residual, independence of observation. We are checking this, right? Now, what I'm going to do when I click this Darwin-Watson on this one. Yeah, when I click this Darwin-Watson, I can get the Darwin-Watson. What is the Darwin-Watson score? Static score
1.213, sir, and
213.
1.853.
83. But you can check with the M1 model only. M0 model, nothing is that. You can see 000. You can see this M1. You can see this model. Actually, model 1 only, default M0 taking this, but you can take the model 1 only. Take this M1. I know also where is come. Take the M1 model only, because there only your dependent variables there. Take this only one model. Take only M1 score, right?
Yes.
So if you go with the M1, what is our status? Is Darwin-Watson value
853.
1.853. Whether it's satisfied or not.
Satisfied, sir.
Satisfied.
Yeah.
It is satisfied.
It is.
According to this, what is the need? We need to up to 1.5 to 2.5. It is acceptable. Therefore, the independence observation is to be acceptable, right? So we are cross-checking this. Any doubts? Darwin-Watson is satisfied. Right now, can you go the tolerance and VAFI? What is called tolerance? What is the purpose of using the tolerance?
Multicollinearity, sir.
Multicollinearity. You can say multicollinearity, VAFI, and tolerance. Okay. VAF score less than 10 is needed. Tolerance scores greater than 0.10 is needed. Okay, according to the Harry et al. Now you can see this. Where is the table? Where is the table? Tolerance here. See this M1. The tolerance score is 1. VAF score is 1. So what about the interpretations? VAF is less than 10. But what is our VAF? VAF 1. Therefore, it's satisfied, right? But in the case of tolerance, what happened? The tolerance, it is also 1. But it's not be satisfied. But at least we can set only 1. VAF is satisfied, no? Let's go with this. Okay. At least because both is talking about multicollinearity. So both is talking about multicollinearity. You can take this multicollinearity, any one multicollinearity only. Okay. So you can see
That
this
says more than 0.10. Huh?
Oh, it's more than 0.10. Then correct. Sorry.
Yeah, then
more
it's
than
correct,
0.10.
na?
Correct. You are correct.
Yeah.
Right. Sorry. So it is 1. Therefore, more than 0.10. That's also satisfied. Sorry for this. Right. The VAF only less than 10. But in the case of tolerance, it will be greater than 0.10. Right. It's greater
Both
than
satisfied,
0.10.
sir, I think. Both
Both
satisfied.
satisfied. And Darwin-Watson also satisfied. Therefore, we have 2 assumptions satisfied. Which are the assumptions? Independent observation, homoscedasticity. Okay. The normality, we already know the data sets. If you want to check, you can go with this. Where is that? In the case of a normal histogram, or you can go the QQ plan and go into check. Right. And the things go to the plots. Suppose you want to get some kind of graphic representation, go to the graphs. And we have the graph like QQ plot standardized residuals. Now we can see this is talking about normality also. What about this data sets satisfied? The residual error. It is also satisfied the normality. How it will be normal? Because most of data are lies on the above the diagonals only. Therefore, it is also satisfied. Therefore, which also satisfied? Normality also, right? So now I'm just going back to the, yeah. So we need to find this, right? This is a plot. If you want, you can go this, go to statistics. The statistics we are finding only the dimension as well as the tolerance. Only these things, other things not needed much. So in the case of display, basically default is to be select the model fit. Now, what is my hypothesis in this case? The hypothesis that the independent variable predict the dependent variable, or the independent variable contributes the different. I'm just making this hypothesis. There is a significant contributions of study habits on the achievement. The significant contribution of, or the significantly the study habits predict the variable of achievement. This is the way we are preparing a hypothesis. This is called model fit. Whether the that model no, with the hypothesis model, whether it should be satisfied or not. But what is my hypothesis? There is no significant. What is my hypothesis? There is no significant contribution
of study habits on achievement.
Achievements,
on
sir. Achievements.
achievement. Now we can see this score. You can see this score. This one. It
On our
is
table.
ANOVA table. What is the ANOVA table? What is the ANOVA table talking about? Is talking about
It represents the
model
model
fit.
fit,
It's
sir.
talking about model fit. It is significant or not?
Yes, sir.
It is
Significant.
significant or it is
Significant.
significant. It is significant, right? It is significant means what? Your null hypothesis. Null hypothesis.
Rejected.
Null hypothesis. Okay, null hypothesis rejected. Then what is the finding? There is a significant contribution of
Contribution of
study habits on
achievement.
study habits on achievement.
Achievement.
Once it is satisfied only, you can see this down table. Listen, if it's significant only, the second table is a valid. I mean, third table is a valid one. If you're not satisfied, even this particular data, your independent variable, independent variable cannot be contributing, means you cannot do the further analysis. We can stop with this. The significant only we need to look onto the next third table. Otherwise, no need is. Hope you are getting this. And one more thing, the R square value is talking about how the independent variable, what is that? Actually, if you multiply it by 100, the percentage was 73.3. So 73.3% of variances, it affect your independent variable create variances
Influences
in
the-
the,
in the
it's,
dependent
influences in the
variable.
case of dependent variable. 73.3% of influences or the variances create the influences in the case of dependent variable. Therefore,
Dependent
your effect is high, 73.3% of influences. That also good results. I'm talking about single variable only. Now we need to write here regression equation. So you need to check with this R square value. We need to check with this the model fit. Now we identify that there is a significant effect of. So there is a
Sir, what
significant
about, sir,
contribution
R
of.
value, sir? R value,
So
sir.
R value, we can write the R value is nothing but the relationship between the study habits as well as the study habits as well as achievement, that R value. But we can write this, give the importance to R square value, multiply by 10, multiply 100. That is called that much a percentage of influence to the independent variable, dependent variable. So normally the R square is a multiplication only. Just so you can multiply, you can get this. But we can write the interpretation based on the R square. I will give this model also, how to write the interpretation also. Now the next thing what you can do, we need to write a regression equation. So what is our dependent variable? What is our dependent variable? I'm writing the equation y equal to ax plus b, right? Or a plus bx, right? A is a constant, that is called coefficient of that is called constant, that's the intercept, and b is the coefficient of x, right? Y, what is y in this case?
DV.
It is achievement, sir.
Achievement. Therefore, achievement is equal to, take this one only, intercept M1 only, take this M1, not in the M0. We can take unstandardized score. We can take unstandardized scores of these two. Intercept score is nothing but constant score. Therefore, achievement is equal to 15.20 A, right? Plus, what is my B? Steady habits, right? Steady habits 0.52 times of, what is this? Steady habits. This is my regression equation. Therefore, achievement is equal to A is equal to 15.20 plus 0.52 times of steady habits. If I know the value of steady habits, I can be able to find this value of achievement. Is it correct? Suppose the steady habits mark 10. Can I predict the value of achievement? Just to substitute the value, you can get this course of achievement. This is called regression equation. This is called regression equation. Any doubts? Any doubts? Right. So
Why do we
now
take
I
this
just,
unstandardized, sir?
yeah. So now in the case y is called unstandardized, I'm taking as a raw score as it is. The difference between standardized and unstandardized, suppose you want to compare a centimeter to centimeter. For example, steady habits, I conducted for the 100 mark, right? Or I can conduct, you can see the score itself, we can get it. So what is my scores of steady habits? What is the score? Minimum score? It having one
Two
minimum
digit.
score might be 90 and the
87.
highest score may be 107. But in the case of achievement, every score is within 100 only. Right? Can I compare with 100 mark with 120 mark?
No,
Once
sir.
examination I can read for 100 mark. Another examination I can read for the 120 mark. Can we compare it?
No.
If you want to compare, what you can do?
Convert the
If you want
both
to
into
compare,
equal measurement.
Correlation.
we can no. If you want to compare it, we need to make it uniform. For example, you have the 50 mark one examination. I'm just giving this. You have the 50 mark one examination. Okay. You have the 50 mark one examination, 100 mark one exam. You want to compare it. You want to do the correlation. What you can do? We want to convert this 50 mark into 100 mark or 100 mark into 50 mark. Then we can get the 2 mark is not 50 or 2 marks and 100. You can compare. Is it correct? That is called standardized. For example, I have the height and weight. Height is a measure in what manner? Height is measured by
Centimeter.
centimeter. Weight is measured by
Kilogram.
kg, sir.
both the same measurement.
No, sir.
Suppose I want to compare height and weight. Can I compare? Because height is a raw score, weight is a raw score. If you want to compare, that is called unstandard because both is to be different scales of measurement. We can measure it. But if you want to standardize in a single pattern, that is called Z score. You know that there's called Z score.
Yes, it's a score.
So Z score, we can convert the height into Z score, weight into Z score like a common score. Instead of converting a height into weight or weight into height, I can convert height in a Z score format, weight in a Z score format. I can compare two Z score together. That is called standardized score. You got it? Standardized means if the unit wise same, then you can go standardized. But in this case, I'm using the different scores pattern, right? Therefore, we can go with this unstandardized.
Unstandardized.
So understood what is the purpose of
Yeah,
unstandardized?
thank you,
Yes,
sir.
sir. Yes, sir.
Yes, fine. Right, now you can see this once again. Now we are getting this regression equation in this case. Right, now can we go with this one more analysis like multiple linear? Can you go with the multiple linear? Right, now what I'm going to do, I can just keep the attitude also. Therefore, number of independent variable,
Two, sir.
number of independent variable 2. Right, now you can see I have two independent variables. It's called as an multilinear or a simple linear?
Multilinear.
Multilinear. Now you can see the Durbin-Watson M1. You can see the M1 model 2.
2.251, sir. Means that is
It is
also
acceptable or
satisfied.
not? It is acceptable or not?
Yeah,
Yes, sir,
within
acceptable, sir.
2.25.
Within 2.25, it is acceptable. Sorry,
Yes.
1 minute. It is acceptable. It is acceptable. Okay. Now this is acceptable. Now you can see this p-value.
This is also not
What is our hypothesis? What is my hypothesis? Anyone tell me what is my hypothesis? There is no significant
Effect
contribution
no
of
significant
contribution of. You can use the word contribution or prediction. Okay,
Yeah.
not effect.
There is
There is no
no
significant.
significant contribution of study habits and
Study
attitude on achievement of students.
Okay, fine, great. Right now, whether the your hypothesis, what is the solution now? The model fit or not?
significant. Sir. Model is fit.
Significant means model fit. What is the meaning?
Fit.
There is a significant contribution of study
Contribution.
habits
And
you
attitude
can
on
see this.
achievement.
On achievement.
achievements. Both is creating effect on the achievement. Therefore, it's a good model. Right now, we can see this. One more thing I forgot to tell you before. Now you can see this whether study habits and attitude separately contributed. For this, we have the T scores. You can go with the study habits p-value. Therefore, study habits significantly contributing. Attitude also
Significantly
significantly contributing. Therefore, what is the
Both.
meaning? Both study habits and attitude significantly contributing in the case of dependent variable. What is the dependent variable? Achievement. Right. What is the equation now? What is the equation? Therefore, achievement is equal to. Anyone tell me the equation?
A
What is
plus
it? 3 point.
Plus
A
3.29.
plus
291.
B1x
29 plus 0.44 points of
plus
study habits.
Study habits plus
plus
0.370 into attitude.
Attitude.
You got it? Attitude. All right. I'm using the enter method. All stage I done it. I done it entirely, right? So I use the two attest stage I done it. Now I'm adding the third one. You can see this. I'm adding a third variable. So motivation. So I have the three variables now, right? Whatever the Durbin-Watson satisfied, right?
Yes.
yes, sir.
Yes, sir.
VFA.
That is also satisfies.
VFI
Tolerance
is
and-
less than 10 is okay. Tolerance
Yes, sir.
greater than
Greater than
point.
0.10.
That are satisfied, both satisfied, right? Now we can see this, our model
That is also significant. sir.
Significant.
Whatever.
significant. This is satisfied. What about this R square value?
83%.
83%. Compared to the single,
83.5%.
previously only what is the percentage single
70.
variable?
73 years.
Now you can see that when you go to three variable, your contribution is more high. So the three variable, 83% of 5% of variances, it create influence in the dependent variable. Right, is a good model there.
Correlation also good, sir. 91%.
Correlation also very good. Okay, the multiple correlation. Now we can see this. Now we can see the steady habits significant or not. Now I'm
Yes.
checking this individually. The model telling this is significant, but I want to check whether individual variable having the significant or not. Okay, individually it is significant. What about steady habits?
Significant.
Significant, sir.
The other
Attitude?
two are not
Not
significant.
Not significant.
Not significant.
Yeah.
Not
Now
significant.
this is case we cannot go the enter because when you go with the enter method, what happened? Two of my variable, the total model is significant, but two of my separate individual independent variables not create contributions. When you go to the fourth one also, you can see this. I'm just clicking this test also. When you go to the 4, what happened? So you can see this, the contribution, how many percentage? 88%.
88%.
Increased.
Model fit.
Significant.
Significant.
Model fit. But you can see the steady habits, steady habits.
Significant.
Significant, sir.
significant, right?
The stress is also significant.
Only stress, but other two things are.
Not significant.
Yeah.
Not significant.
Therefore, what is the meaning? Out of 4 variable, even though model fit,
Yeah.
but only 2 variables are contributed well. Then what you can do, think about to change this method of enter. Because when you go with the enter method, you're taking all the items to all the variables is running this linear regression. Instead of that, we need to think about this one that is called stepwise analysis. Under this, we have a backward method, forward method. I'm just giving this example. What is the difference among these two? I'm just giving this. What is the last slide? Okay. Yeah. So I'm just giving this idea. What is called forward method, forward stepwise, and backward elimination. So in the case of enter method, so what it done it for the enter method, what it done? I'm just highlighting. So for example, I have the 4 independent variable x1, x2, x3, x4, right? All the 4 variable, it's automatically how it's affect on the y. This is called enter method. It is called enter method, right? But in the case of forward method, what we can do now? So out of this much of 4 variable, here we can find the most significant contributor. For example, out of x1, x2, x3, x4, x3 may be the good way is contributing to the y. Therefore, the first, it's called stepwise. Instead of going with all together, the first one taking as an x3 first. x3 with y, we can check. Then second, the first level, this one. Second is showing that more significant other than the x3 is called x1. You take the second one, right? Therefore, x3, x1, how it's affect the y. Then third steps, see the step number 1, step number 2. The third step is finding that the other third variable x2 is creating a more significant in the y. Then go to the x3, x1, x2, then y. But the fourth step, suppose the export not contributing well, it may be eliminated. It may be eliminating. Don't know it. Only your 3 variables only contributing. Therefore, you can write the interpretation based on only the 3 variables only. You can write the equation for x1, x2, x3 into y only. You cannot write the interpretation based on x4. You got it? Because automatically it's going to avoid based on the less significant contributions, the particular variable to y. This is called forward method. Forward method start with the 0, go with 1 by 1. So any doubts? Forward method. So it's going to find out of 4 or 5 independent variables, which variable having more contributions or more significant in the dependent variable. That only taking the first step, right? Step number 1, step number 2 is going like this. Step number 3, step number 4, right? So finally, if any variables are avoid because there is no significant contribution up to this, that forward may be over. And the next method is called backward. In the forward, we can start with the 0. We are not using anything, all the x1, x2, x3, we are not using directly. We are taking this, the powerful one only. But in the case of backward method, we are removing one by one. First, we can start with the full. We can keep x1, x2, x3, x4, all the 5 we can keep it. First round. Second round, when we can do this, out of this, we can find out which is the variable less contribution that we need to remove. That variable we need to remove. For example, out of this, x4 is to be very less contributions. Then remove this. The third round, out of this 4 variable, which is a variable more or less, that is the next 2. Like this, we can find, and finally, we can find only the significant variables only. Only out of 5 variables, only 3 variables are significantly contributing to dependent variable. That only we can keep with this. And that is the way we can write the regression equation also. This is called backward stepwise selection method. Hope you are getting this. Forward method start with 0, null, and it taking one by one step based on the most significant value. But in the case of backward method, start with the full and remove one by one based on the lowest significance scores. So can we do this now? Right? So now we can see this. What I done it now, I have all the 5 variables, 5 independent variables. 4 independent variables. Now kindly check this. Otherwise, I can go with the new linear regression. Can I go with the new one? Keep it the same thing. I'm going to the new linear regression. Go to the linear. Create in linear. Now, what is my dependent variable? Achievement. Keep it other thing as an covariate. Okay. The same results comes. Select all the things which are, go to the statistics. Select this Durbin-Watson and tolerance VF. This only is enough. And now we have to check. What is this model? It is the entire model, right? Now, what I found from this, from the entire model, I came to know that the 2 things are not satisfied. Which are things not satisfied? I mean, not be satisfied. Significantly contributed. Attitude and motivation. This is a 2 variable. Someone's going to delete. For example, you can see when you do the further analysis, some of variable going to remove from this. And just going to the forward method. What is called forward method? Forward method start from 0.
Most significant.
It start with M00, then M1 most. It take only one most significant value. The second round taking the 2 significant. I'm taking the forward. When you go to the forward, number of MO, how much comes? MO means what?
0.
0, null, right? M1 means only 1. M2 means 2. M3 means 3. M4 is not there. Why?
Because less.
That's from
It may be less. It may not be affect. Now you can see this coefficient where you can get this. M1, it is only for
Study habits.
study habits. Therefore, from the model, you can find this, which variable more contributions, more significant.
Study habits.
Study habits. Go to the second model, second steps, study habits and attitude. Therefore, second level, what is the contribution happen? Attitude. Go to the third one, study habits, attitude, stress. Now we can see the p-value of third model.
Seems to be significant.
All seems to be significant. You got it? All significant. But you can see this is the first model. When you go to the entire model, 2 is not satisfied. Therefore, when in this context, we have to go with this stepwise. You can go the forward or backward. Anyone you can go with this. Forward means what you can do? Start with the 0, go with 1 by 1. Step 1, taking one variable of the most significant value variable. Second level, third level. And finally, up to the variables removed up to this may be going on. Therefore, this particular model may suitable only for how many variables only? How many independent variables only? 3 independent variables only. Now we can see this. So, but when you write in the interpretation, can we take all the 3 model? I mean, M1, M2, M3, or you can take only one model, which is better? Take only one. Which one I have to take? Anyone? This is a multiple linear. Which model I can take it? Which model I have to take? Yeah, we can take the third one. What is the R square value?
88.1.
88.1% of variances in the case of variances influence in the case of dependent variable from the independent variable. Then take this M3. What is our p-value?
Significance.
Then what is the results? There is a significant contribution of study habits. Then
attitude and stress.
Attitude and study. Then now we can see this case. What is the final output? you can say this, all the fours are significant. Our tolerance also, it is point greater than
Less.
0.10, satisfied. It is less than
10.
2.5.
10. It is less than 10. That are satisfied. Is it
Yeah.
correct? It is less than
Yes.
10. It is above the 0.10. Both are
10.
satisfied. Now you can say this, the urban Watson also, it is 2.43 is less than 2.5. All
Five.
things are satisfied. What is my regression equation? Achievement is equal to anyone?
53
Study
point.
habits.
3.643
64. Two digit you can write. 0.33 kinds of
into
study habits.
study
Yeah.
habits
0.28
plus
Plus
0.28 into attitude
very good.
plus
Minus.
0.52
Plus, yeah. Why that minus comes?
Negative.
Minus because the stress is creating negative. Automatically
Negative.
stress is creating negative influence in this. So you can
Oh.
change this in minus. Okay, minus 0.52 times of
Stress.
stress. So now we understood. In the case of
Yeah.
attitude is a positive way because attitude may be positively affect the achievement. Study habits also positively affect the achievement, right? But stress may be negatively affect. What is the meaning? Stress is increasing, scores may be less. Stress is reducing, the scores may be high. Therefore, perfect. So this is called what method?
Forward method. Multi.
It is a forward method. Okay. It
Sir,
is a
should we
forward
mention
method.
about this motivation, which is completely eliminated?
Yeah, we can highlight. No need for this because that automatically is eliminated because it's not the creative effect. It's not contribute well. Okay.
While we are pasting that chart in a Word file, then we have to delete that first M1 and M2. Only we
No,
keep
what you
that.
can do, you can copy it everything because they must know which model you done it. We done it here forward model. So then only the people know that it's a forward model because we have the M3. But write the interpretation based on only M3. You got it?
Yes, sir.
Because if you go with a single model, I mean a simple linear, the entire model, only one M1 only is there. There is no M2, M3. But when you see this, automatically people know that you've done it stepwise. Okay. It's up to you only. Even if you go with the M3, no problem. But you can specify what model you are using it. So when you go to the backward model, sometimes I'm just going to the backward model. Okay. So I change this backward model. Now what happened? You can see this. Okay. I'm going to the forward model. I'm going to the backward now. Yes, what happened to the backward model? Backward model start with
The least
start
one.
with
all the stack.
no all.
variables.
Then remove one by one. Remove one by one. Now you can see this output also. M0, it is for the entire. M0 for the entire. But we can go with M1 only. M2, M3 is not there. Why? Because it's reducing only one variable only. You can see this, the same results. Study habits, attitude, stress, the M1, which may be removed.
Motivation is removed.
Motivation. You understood? Forward also removed by motivation only, removed motivation. Here also removed motivation. But in the forward, you get the 4 steps, M1, M2, M3, right? M0 along the 4. But here, how many only comes? Only
Just
2.
only one.
M0 totally, M1 remove 1. That is called. Then if you go with the M3, what happened? M2, it automatically standard comes. There is no need to remove it, right? Because there is no less than that. Automatically, we can remove the less significant value. All the 3 variables are significant contribute. That's the reason it's not removed. So now you can copy and you can see the significant value, significant. This is called backward model. Any doubts about the forward model, backward model? Any doubts?
No, sir.
Can you go the stepwise model? What happens stepwise model? What happens stepwise model? The same thing only. Instead of forward, you can see this. How many models there? M1, M2, M3, M4 is not. You can check with this first one, M1, M2, M3, and the same. Once again, which is removing now? Which is removed?
So it looks same like
Motivation.
forward model.
Same like a forward, same like a forward.
Forward.
Actually, in the stepwise only, there is a forward backwards. That's called stepwise. Okay. Stepwise having a 2 model. One is a forward model, other one is for backward. Okay. It taking is a forward model. So hope you are getting this when you can use this regression, right?
Yes, sir.
Right. Now, can we go with this default data which is available here and just go? I request all to open this data set and make it a regression equation up. Go to the open, go to the data library, go to the regression. In the regressions, yeah, there is an second one, album sales, no? Third one, second one is album sales. Kindly click this one, data set. Click the data set, okay? Click the data set. You are getting the data set, right? How many dependent variables? Sorry, how many variables is there totally?
4.
How many variables is there?
4.
Four, right? Yeah, the problem you cannot get the output, but suppose you want output also because you don't know how the output maybe comes. So I'm giving this one more idea. Instead of clicking the data, click this, click your open, go to the data library, go to the regression. Instead of clicking this word file, this one, open the data file, go to the first one, open a JASP file, When you click this JASP file, you can get this output also and interpretation also. You got this? Suppose you forget what we talked. So you want to be learned from you. Click this, automatically they give an output with interpretations. This is the way this tool is better than other tool. You are getting the interpretation, right? Go to they are highlighting descriptive statistics for checking the normality. I request all to click the last one, linear regression. What is the linear regression they done it? What linear regression they done it? What is the method? Sales is an independent
Sales,
variable. Sales independent variable. 3 is the independent variable, which is called advertisement. Actually, what it means, the sales of the album. There is a music. The album sales, they're checking it. The album sales depends on the advertisement, airplay, the number of times they played in the TV channel, the music, the attractions, whether the music attraction, the composer attractions, that is the things. When it's seeing the score, advertisement is a continuous variable, sales is a continuous, airplay is a continuous, but attraction
ordinal.
Chandra is an ordinal. As already mentioned, no? Ordinal also possible to doing a regression equation, right? Regression is possible. So what you can do, now if you go back, you can see the same answer. So now they run it here, M1, M0, M1, through the enter method, you take the M1 only, take the M1. What is our, this one, sorry, R square value? What is R square value?
66.5%.
66.5%.
5%.
Then 66.5%, the variance, it's the independent variable, the variance is dependent variable. Okay. Now we can see this one more thing. Here that this is not visible. What one Darwin-Watson is not visible. How to click the Darwin-Watson? Click the statistics. Click the statistics. Where you can go the Darwin-Watson? Yeah. Darwin-Watson. Kindly check whether it's satisfied. Yeah, it is satisfied. You can check with this M1 only. It is 1.5 to 2.5. It is satisfied, right? Go with the VAF. Tolerance VAF. Tolerance VAF. The tolerance VAF score is greater than, is less than 10. It is also less than,
More than
greater than 0.10. The both are satisfied, right? Now you can use model fit significant, right? Model fit significant. Then you can see this 1 by 1 p-value. Advertisement significantly contribute. Airplay significantly contribute. Attraction also significantly contribute. Therefore, what is the findings? What is the equation? What is the equation?
It is the sales equal to
Sales is equal to
minus
0.08,
26.
right?
yeah. Listen, minus actually the
Minus
minus.
26.
Therefore, kindly add this minus last instead of constant keeping first. You can add the minus. So you understood because the minus start means equation minus not be good. So I just started with the equation like this. So what is the equation? Sales is equal to
0.08
into advertisement
0.08
0.08 times of advertisement
plus
plus
3.36
3.36 times of
airplay
airplays
airplay plus
11.08
08
times of
attract.
Attraction.
attracts
minus
26.61,
26.
right? So this way we can write the equations. Okay, this is called regression. What it identity multiple linear. In this case, whether we can go with the enter method is stepwise needed. Stepwise needed.
Not needed because all are significant.
Yeah. If it not significant only, you can think about the
Changing
stepwise.
a
But in
method.
this case, all the fours are satisfied. All the three variables are
Significant.
contributing. Therefore, no problem. Okay. If
Yeah.
it not satisfied only, you can think about which method stepwise. Right.
Right.
So can we move to the factor analysis now?
Sir,
Right.
this A value is in minus, no, sir. So what does that mean? How to interpret that, sir?
Which value, madam? Minus?
Minus 26.
Constant value.
Intercept.
It's a constant value minus is reducing. For example, I'm giving this example, madam. So that meaning is that the equations will be the constant value is reducing the score. For example, I'm telling this. Suppose I like to buy a pen. So I'm going for a pen. So I'm just writing the equation, for example. Okay. Right. Right. So I like to buy a what is this? So I'm going to take a food. So right. So food. So I'm like to take a food. The expense which I made is called my what is that? My expenses. It is my dependent variable. So what I'm eating, no, that is the prices like what I'm eating, the number of quantity. For example, I'm eating a brota. So or 10 brota I'm having. Each brota is 10 rupees, right? Therefore, if you have a 10 brota for 10 rupees, how much, ma'am? 100 rupees.
100.
Therefore, expense 100. Here, the brota, it is B, X. How many independent variable? Only X, right? Then the 10 brotas, it is my coefficient, right? Then next, plus, I'm sitting in the AC room. That AC room costs 10 rupees. It never be changed, right? Right? Therefore, automatically my amount, how much I expect? 110. Suppose I'm having a 5 brota. How much?
50.
No. I'm having a 5 brota. Constant is there, no.
60.
This called intercept. 60. This constant never be changed, right?
Okay.
For example, whenever you're eating this is called plus. Suppose this hotel giving a 10% of relaxation of your food. This was the plus, okay. So when the AC room, they give the 10 rupees. When you go with the enter, for example, they give some get a Diwali offer. They're reducing 10% of the food. So whenever he's sitting there, whenever the rupees comes, 10 rupees less. So that is called intercept. So you are having the 50 rupees means they will ask only 40 rupees on. You got it?
Okay, sir.
The way it's coming. So some of the scores, it will be constantly there. I can just give the example. When you go to the hotel, I give this. But you can see about the research, you can get this. Intercept is like that starting point that is called from when you go to the x-axis, y-axis, that starting point of the y is called intercept.
Okay.
Okay, sir. Thank you, sir.
Okay, fine. Okay. Right. So now, can we move to the factor analysis now? Sorry, ready now. Right. Before that, the people are asking this one, like item analysis. I'm just giving this item analysis. So I have some data, but instead of this, I request all to open in this data set. Go to the open. Go to the open.
Can you also show us one non-parametric regression?
Yeah. So, madam, if you want, I just give this. Go to the regression. Go to the data set itself. They given this. That is called linear regressions, Pearson regression, linear regression, Bayesians, linear regressions, intercept, Kendall Spearman, logistic regressions, binomial logistic. Yeah, so you can see this, they given the binomial logistic regression. Okay, click this data set. You are getting this entire things here, right? The hours, turbulence, and the pressure. This is a generalized linear model, dependent variable, covariate, total number of trials, turbo lines. You can see this. No, this is not a 1 minute. In the case of dependent variable is wrong. In this case, 1 minute. It's a wrong data. Just go into the regression model of it. Open data library, regressions, kindly find out the regressions. This for linear regressions, Pearson correlation, linear regressions, Pearson's linear regression, Bayesian, linear regressions, interval, Bayesian linear, Spearman, logistic regression, sorry. So there is a logistic regression data. Click this. You are getting this idea. So now what is the dependent variable?
It is
Square by
nominal, sir.
Your dependent variable? Nominal.
Nominal.
Automatically you can see this nominal. What is my independent variable? They use the two
Sir.
independent variables. One is the age, other one is called PC
Class.
class, right? Now the same way you can write this, okay? So, but the M0, they're writing all the interpretation here because I'm not the person, I'm not doing the non-parametric. So all the interpretation is there, kindly check. Even when you read this, you may get this idea, right? So because our education, we are not using this non-parametric and this logistic regressions. So they given how to write the interpretation that down and the scores also. And what is the lambda x square? What is the p square? You can see p is also significant. And the estimate standard error, the odd ratio. These are the interpretations also they given this. This was some other additional table also they given. So kindly go through this because they given a lot of data sets to further explore the different data analysis because they have a lot of data analysis. Most of the data analysis we are not using regularly. So if you want to explore the other data analysis, also when you click the data, we can get this some idea how to do this analysis, even the non-parametric and all. Hope you are finding this map. So kindly
Yes,
look
sir.
onto
Yes,
this
sir.
output.
Thank
You
you
are
so
getting some
much.
idea. It gives some idea. Okay. This is the data sets explanations, right? Now, can we go with this item analysis? I go very firstly item analysis. Go to the open and go to the compute data library. In the case of go to the reliability. Go to the reliability. In the reliability, the first one, fears of statistics. So actually, there is a tool, 2,571 samples. This fear of statistics. I request all to click this data only and just explain the data. No need for the first one. Go to the data. The second one, you are getting the data set. You are getting the data set, right? How many items is there? How many items? How many items? 23 items. 23 items. It is on 23 items there, right? It is on 23 items. So I'm going to do the item analysis. Under the item analysis, there is called Cronbach Alpha. It is for reliability
So
analysis,
which
right?
file
Cronbach
do you
Alpha.
select?
Sorry, ma'am.
So which file do you select for this one?
Go to the open data library. Go to the reliability because we are reliability. No, go to the reliability data. 13. Under the reliability, because each one's different heading. Okay, you cannot use all the data for linear analysis. The first one, fear of statistics. No, they conduct some
Okay.
analysis. Sorry, research fear of statistics. Go to that data file only, not in the output file. So you are getting this file, right? So this file consists of 23 items. Whether the 23 items is a nominal, ordinal, interval, or ratio.
Ordinal, sir.
Ordinal.
Why is an ordinal? It is a Likert scale. Listen, why it's an ordinal? It's a Likert scale. Each item is a 5-point scale or 6-point scale. They made like this. Therefore, it seems it's a 5-point scale. Therefore, I have the 23 items. And do you know this item analysis, number of item analysis, number of types of item analysis? People are doing the different item analysis. Okay. Just very fastly, I'm briefing it. You might do, when you go with this, 1 minute. When you go with this achievement test, suppose you like to prepare an achievement test. Okay, sorry, I thought to write something, but the system not supporting. I'm going to open board now. All right, I hope you are seeing this. In the case of this one, like item analysis, we have a different process. One, we are doing this item analysis in a different way, each one's. When you like to do the item analysis for the achievement test, the people are using the discriminant index, difficult index and all. Discriminant index and difficult index. So that is people are doing with manually. So that is for the achievement test. Suppose we have the scale variable or awareness, scales or awareness or any kind of scale basis you like to do the item analysis. The people are using a t-test. Even the people are using the chi-square test. The people are using a then even the Z test they're using it, and one sample t-test also they're using it, and they're using the item with item total correlation. Item with item total correlation. And these are the item analysis techniques. In the case of t-test, what they're doing, no, they're going to compare with that IHO row. For example, I have the 100 students. If you have 100 students, 100 participants, take it at 27% of IHO, take the 27% of low achiever, and you can do the analysis for the each item. Item 1, whether high achiever, low achiever t-test, whether significant, not significant. If significant, the items are retained. If not significant, remove this item. Item number 2, compare the 27 high group achiever, low group achiever of the item 2. If the significance it's happened, the items are retained. If the significant not there, the items are removed. This is the way that we are doing. This is similar the chi-square or the and there is one more item total correlation. For example, you have 5 items, each item with the total score the comparison that people are using it. But parallelly, the people are using for item analysis. This one also Cronbach if item value, if item deleted. Cronbach if items deleted. This is the way also the people are item analysis. And parallelly, the Cronbach value is part of the reliability score. You know the reliability, we have the different reliabilities. That one is called Test-Retest, other one is called parallel form, other one is called split half. Then parallel, we can use this kind of they're using the kinder K20 and all. So, okay, there is no one more. Then another one that people mostly that we is the Cronbach. Okay. The Cronbach is a very powerful one. You can use the Cronbach. This much of item analysis that people are doing, and just going to very fastly the item analysis things to you, right? It is not a variable. Yeah. So how many items we have? 23 items, right? And this then scales. Some items may be negatively, for example, you know the scores, no? Some items are 1, 2, 3, 4, 5. Some items are 5, 4, 3. It's a reverse scale also. We need to do this. And go to the reliability. Go with the unidimensional reliability, unidimensional. When you go to unidimensional, we have 23 items. Just select all 23 items. You can put it there. We can put it there. So you can just drag and drop, right? You can put drag and drop. And go to the analysis. Basically, selecting as a McDonald W. McDonald as a coefficient of W is a part of the reliability. But select the alpha, that is called this one. What is this?
Cronbach.
What is it? Cronbach. This is an alpha. Cronbach. So now the alpha value is more than 0.7. It is acceptable. It's reliable. More than 0.7. It is reliable. What is my estimate value? What is my estimate value? 0.754. It's more than 0.7. Therefore, my items are reliable. My items are reliable. Right. Next thing, you can see down there's a note. What is a note? The following item call it negative the scale. Item number 2, item number 3, 9, 19, 22, 23 is negative. I mean, the items are negative. We need to be reverse it. But in the SPSS, this option is not there. We need to reverse manually. The SPSS it never show also. If you show also, we need to do through the Excel only reverse things and all. But here we have a good option called reverse scale item. Are you able to see the reverse scale item?
Yes.
Reverse scale item. So what I'm going to do, out of 23 items, only 5 items are reversely correlated. Go to the reverse scale item. If you go to the reverse scale item, you are getting all the items and reverse scale item. So what are my variable? Second item, select only the item. Second item, 2, 3, 9,
19, 22.
22.
I'm just selecting only 19,
22,
and 22, 23. Now there's a 5 items are reversed. Now you can see nothing is there. The following items are over. Right now there is no error. What is my estimate value?
Now it has
My quotient value
89.
0.89.
is improved. 0.89. Therefore, my reliability score is more than 0.7 is reliable. My tools 23 items consist of reliable. But apparently, I want to check.
For 0.89, that is the Cronbach alpha value, na, sir?
Yeah, that's a Cronbach alpha. 0.89 is a Cronbach. Right? So this Cronbach alpha value. Suppose I want to increase because more reliable. If you near to plus or minus 1 plus 1, it's more reliable. So our intention to increase our what is that? Even though it's satisfied, we need to increase it. Alpha value we need to increase. If we increase, mean we need to delete some items because some of the items not be contributed much. So for this, go to the analysis. There is called coefficients alpha if I top. Are you able to see this?
Yes.
This for the item analysis. The previous one is only for the reliability. And checking this item analysis. When I click this Cronbach Alpha, if item dropped, I can get one more table. You can see there's one more table is emerging. That table base, we need to remove some items, right? So it takes time. What is my estimate value? 0.89. It's already reliable. It's reliable. So I'm just going to take some items to remove. It takes time. How many of them got this score already? The scores? We're done. Just trying. It takes time. It's coming. Anyone's got this output? Yeah, I got it now. Right. So if item drop, our intention to increase it. Our intention to increase it. Now what you can do? Kindly check with my output. My estimate value is point. My estimate value is 0.89.
sir.
It's already high, right? 89. So I want to increase more. Therefore, what we can do, we can cross check the each items. If your Cronbach value, if you're deleting the first item, whether it's possible to increase it. For example, if I delete the first item, what is my Cronbach value? 0.85. It is to be above or less?
Less, sir. Less.
Therefore, when you remove it, it should be above. When you remove it, what happened? Your Cronbach value is less, but our intention to increase. Therefore, this items you can retain. You can retain. This item never be removed. Okay, because this item is contributing. That's the reason. If you remove also, it affect your reliability score. What is second item?
A point
It is less than.
That is also.
It is also retained. It is also retained. It is also retained. You can see this. Any items to be removable. The item number. Item number 9. Item number 9. If you remove it, what happened? We are getting
reliability with score is it will be 0.892. Sir.
0.002.
So can we do this now? And one more item also. Item number 23 also. What is this?
894.
So therefore, out of 23 items, I need to delete the 2 items. What is the items? Item number 9
and
item
20.
number
23.
right? Total items and just removing it. How to remove it? Any idea? How to remove? Go back here. Here, no, don't we go with this reverse. Here, which are the items? Sorry, I forget the item number. What is the item number?
9, sir. 9 and 23.
Select this item from the unit dimension 9 and
23.
23. Now you can see this my value now. Now it's changing now. So any prediction? What may be an answer? What may be my alpha value?
More than 89, sir.
89. But you can see this last one, 23 item. If you remove 0.84,
894 or 5.
it may be more than that one, or 894. Then 894 or more than that one. You can see this. So now my total number of items now 21 items with for the further calculation. The further calculations. So it takes time.
98.
What is my Cronbach now?
898.
898.
From this you can stop. Okay. So this way we can stop. Therefore, having a number of items is what is that?
So now it's showing that if we remove Q22, our value will be 90.
Better you can remove that also. You can remove one by one. The following items also reverse scale. Okay. The problem don't be delete the reverse scale item. That may be affect. Okay, that's the reason. Better you can keep this one. Only one time is enough. Otherwise you can remove all. If you go with this, one by one, sometimes you can remove all the negative items. There will be chances there. So don't go with the only one time you can do this, and finally you can come to the conclusion that your Cronbach value is 0.898. It is more than the 0.7. It will be reliable. This is a way your reliability to be ensured. And one more thing, there is called split off. Suppose you want to do the split off also parallelly. You can do this. Select the split off. So I select the split off. You are going to split off also. What is my split off? What is the purpose of split off?
So to check internal consistency.
Yeah, internal consistency. Actually, Cronbach also internal consistency. But you can see this, the split of his point. Therefore, both the reliability analysis satisfied. Even the Cronbach Alpha also satisfied, as well as the split of also satisfied. Right? This way we can ensure the reliability. Right? This is called reliability analysis. And just close this. Okay, we have a lot of data sets now. Now I'm just going back to regression analysis. Sorry, the factor analysis. Listen, the factor analysis we need to discuss very fastly. We have 3 factor analysis. Do you know what are the factor analysis? Any idea?
Exploratory.
Exploratory.
Explanatory.
Then
Confirmatory.
exploratory.
Confirmatory.
Confirmatory. Then PCA. Then PCA. Okay, principal component analysis. That's called PCA. Right. Now I'm just going to use my slide because the slide I just added a lot of input for more than 70 slide is there, but I cannot use it now. Right. So I'm just showing very fastly my the PowerPoint slides. When we can use the factor. Anyone tell me when we can use the factor analysis? What is the necessity for factor analysis?
For reducing the dimension.
Yeah, of course, reduce the variables. Reducing the variables. Okay. For example, when you go to prepare a scale,
Grouping the variables.
grouping the variables, everything answered. Fine. For example, when you go with a scale, suppose I'm developing a tool ICT attitude or AA attitude, it having a 36 item. When you go with this analysis, no, all the 36 item might be variable. It's very difficult to go with all the items based. Instead, we can grouping based on the characteristics. So, or we can make it some kind of unique, what is that? You can find it some kind of underlying factors that based on we can grouping it. Now, we can see this example. We have 9 questions. The 3 questions may be come to the numerical IQ, 3 questions may be spatial IQ, 3 questions may be a verbal IQ. This kind of reduction. So, reducing a variables, that is called factor analysis. For this, we are using it. They use and just highlighting this main purpose. Even this kind of things we use it for. Sorry, we can use it for the factor analysis, reliability purpose, item quality purpose, construct validity purpose. Even when you use the factor analysis, no, you can use it called construct validity. Normally, the validity we are using, the validity is called face validity. What is that? Concept. What is that? Another one? Face validity, content validity, and content validity, different concepts. But when you go to factor analysis, divergent. But we can use it called construct validity because it's like constructively disapproving. Okay, particularly confirmative factor analysis is very good for ensuring the construct validity because you already have the theoretical science. Based on this, you are developing a tool and you are confirming that whether these items are lying on these particular factors. That is the reason we can use this kind of confirmative factor analysis. Now I'm just giving the small overview about this path. It's like a path diagram. Basically, it's called path diagram. This is a factor, F for factor, right? Normally it's called latent variable. We may call it a latent variable also. And this X1, this XX, no, X1, X2, X3, that is called our observed variable, like items. Item 1, item 2, item 3 is a measured variable. And when you go with there will be error also may become, that is called residual error. And just, yeah, please kindly take the screenshot. This is giving you insights about when we can use the CFA, when we can use the PFA, when we can use the EFA. CFA is a confirmatory. Suppose you are developing a tool that also based on some component. You already have some theoretical knowledge. Based on theoretical knowledge, you develop a tool, and that tools you want to confirm whether these items are lying on the particular component. Then it's called confirmative factor analysis. For example, I'm developing a tool for confirming this personality. That's a big 5 model. I already made a tool based on the 5 dimension. I already categorized the dimension. Finally, I can ensure that whether all the items are lying on the particular dimension. That is called confirmatory factor analysis. Already have the predetermined model or theories that you can go with the confirmatory. Particularly, go with this, that what is that, old variable. When you go with the new variable, you can find this kind of theoretical sites. If you have already existing variable, a lot of people have already done it, automatically there's a lot of theory maybe support, then go with the confirmatory. PFA and EFA is called, basically it's an exploratory. And sometimes even some textbook they highlighted that PFA, EFA look like a same. Only the difference, the PFA is excluding the unique variances and EFA taking this unique variances also. There's only the difference between the PFA, but most of the process they PF and EFA, you can go with any one, PF or EFA. Both look like the same only. Only the difference is unique variance. It will be excluded in the case of EFA. But the unique variances, it will be taken by the EFA, and give this some diagram also. And another thing, I give this some example also when to use it. You have the theoretical model. If you have the theoretical model, and you want to test this. Yeah, theoretical command. I want to test whether the data fit into this. There's a meaning with the data is fit into the order, that particular construct. I'm talking about construct meaning factor. So the construct having a 5 items means whether all the 5 items are lies on the particular construct. That we are checking the confirmative. PFA, you want to identify underlying latent factors. That's called latent factor, nothing but the factor construct, but only consider the shared variance only. And you don't know the you're developing a tool, but you don't have any theoretical support and you don't know idea about this, then you can go the exploratory at PFA, and you want to explore the latent variable, you can use it. And one more diagram. This course, if you want to take a screenshot, here I'm talking about the basic thumb rules of the criterion. It will be satisfied in the case of all the things. If you want, you can take this one, is better, yeah, because all the 3 things is there. CFA, PFA, and EFA. I made a single table. Sample size, it will be about 200. CFA. CFA is very essentially it has high sample size. PFA is at least 100 above. And in the case of EFA, 300 plus is an ideal. But otherwise, you can cross check this one. What is the 5 to 10 case per? You can take as a 10. You can take as a 10 maximum. 10 case per variable. What is the meaning? Suppose I have 36 items. The 36 items I am dividing into. Here, cases per variable means what? It will be items or in this one, parameter or dimension. It is talking about each items, right? So it will be more number samples needed. When you do the confirmatory, EFA, we need a more number of samples needed. Otherwise, the ideal is at least 300 sample. Then you can think about the EFA or CFA. Better to be more than 300. And the factor loading, always 0.5 is preferable in the CFA. Here 0.3 is okay, 0.4 is okay. This table you can take it. I will give us interference later. And I'm going to check that. Give some example because you know that the difference between the exploratory and confirmative. Confirmative, we already have the theoretical knowledge. For example, there is in consistency of interest is one factor construct. Precedence of construct is another construct. We have the 3 items of this one. We have 3 items in this. So now none of the items not be correlated in this case. You can see this because the exploratory means we can explore because we already confirmed that this variable may contribute only this only. So I'm just showing this. This x1, x3 is going to contribute only this one only. It never, this x1 not come to this. So instead of the x1, x2, I can put this one, x4, x5, x6, you feel the same, right? It's x4, x5, x6. In the case of confirmative factor analysis, what are the items? You're going to check whether it will be fit on this particular factors only. Similarly, this item, whether it's going to fit on these items only. This is the factor only. This is called confirmative. But in the case of exploratory, we doesn't know where it's going to lie. So you can see the x4, x5, x6. Therefore, what is going to happen? This particular factors is going to check with this relationship loading with all the items. And out of these 6 items, the 3 items loading may be more. That is making as a group. And similarly, these 3 things, the factor loading may be high in the case of precedence. That's the reason there is a 2 classifications. These 3 items lies on this one. These 3 items lies on this one. But parallelly, each has load with the other items also. This is called exploratory because exploratory is going to identify the different items also. But in the confirmative, we are going to look on only that particular measurable variable with the particular construct only. We cannot go with the other construct, other items. That may be fair. And the same thing we discussed. And I'm just showing this. There's a difference between PF and CFI. That's sorry, EF, exploratory factor analysis. Please kindly know this. This is called PCA, principal component analysis, and exploratory factor. That's here only differ. Listen, actually, in this case, this 4 items, 4 measures, is going to drive a dimension. So dimension, right? So it's drive it's leads these 4 items making a group and it's identifying a one factor, right? But here it's ulta. First latent variable that is called as in construct. This construct is going to identify items based on this grouping, based on the characteristics of the latent variable, is going to identify this one. The error mark only differ. So if you want, you can see this. This is very simple. This is an exploratory factor analysis. Latent factors only drive a observed variable. From this only is going to identify the items. The factor identifying the items. The factors drive the observed variable. From this observed variable, it's going to come find that which are the items may be more suitable for factor like this is going to identify. But in the case of principal component analysis, the component is there, but the items only decided which component, which factor may be lying. That you can see this error mark, right? If you want, you can see this that equation. In the case of confirmatory factor analysis, or principal component analysis, I'm talking about the confirmatory factor analysis. You know that we have the equations is talking about we need to find y1, y2, y3, y4. Y1 it depends on the f this b1 that is nothing but a beta value. So yeah, every time y is connected with f and beta 1 and place e1. Therefore, if you want to find the y1, we need a b1 f plus this e1 residual error. Similarly, if you want the y2, we need another, because we need to find y2 means we need a b2 f plus u. This is the confirmatory factor analysis. It's not confirmed, it's an exploratory. In the exploratory, we need to find this is exploratory. But in the case of principal component analysis, it will be ulta, because the C is derived from the this items. Therefore, what it can do, we can find this component C is equal to omega, I mean W1, Y1. This is like a regression equation. It's look like a regression equation. W2, Y2, W3, Y3, and W4, Y4. This is dependent variable. The dependent variable is to be developed from the independent variable, that coefficients and all. This is called principal component analysis. But component analysis will be ulta. We are going to identify this one only. We are identifying the items and items how which each one is contributing. This is a Paul diagram just showing this. The same thing. This is called exploratory factor analysis. This is exploratory. Yeah, now we can do this analysis with our items. Now I request all to new data set. Before that, I'm just opening this one. There is a tool also I attached here. I request all to check with our WhatsApp group. The WhatsApp group I shared the link in the afternoon, the evening. That is called data set. Under this, I added a new the number 9 CFA data set as well the CFA questionnaire. Actually, this is a questionnaire. I hope you downloaded. I request all to download 9 plus 9A. Together you can download. Actually, this is possible for confirmatory, but I'm parallelly running exploratory also. You can see this. This is a tool. This tool is talking about IT adaptation. Okay, IT adoptions. IT adoption having the 2 dimensions. What are the dimension? Enabler. Other one is called barrier. Enabler having how many items? 6 items.
6
Barrier
items.
having a
8
barrier
items.
having a 8 items.
8 items.
Therefore, totally how many items? 8 plus 6?
14.
14 items. So this is already a theory is there. Based on the theory only, this tool is developed. Therefore, which is possible for to run this? We already have a model.
Confirmatory.
It is confirmed because already theory we already made is a different grouping. We can go the confirmatory. So now this data is available in the 9A. So I request all to open this one. We can start with the confirmatory first. Go to the JASP, open a 9th one. Go to the open and open a data set. Browse. Yeah, that 9th data set. CFA data set. Open. Okay. So we have a serial number. And A1, A2, it is called enabler. B1, B2, B8 is for the barriers, right? So confirmatory factor analysis, how many factors am I having? How many factors?
14
factors. No, 2 factors.
No, 2 factors. So it's already theoretical model is there. That's the reason which one I have to go. Which model? Go to the reliability, factor. Listen, one more thing you must be aware of it. SPS we cannot do with the confirmatory factor analysis. Why? Anyone? SPS we cannot take do the confirmatory factor analysis. Why? There is no option for this. It may be supporting only the principal and exploratory. If you want to go with the confirmatory factor analysis, the SPSS we need this one. What is Ramos software?
Ramos.
Through the Ramos software only you can use the confirmatory factor analysis. You cannot do only the SPS software. You cannot do the confirmatory. But you can see this software is freely available. we can do all the three. Confirmatory factor is not possible through the SPSS. If you have the almost only can possible do this, but I'm doing this here and go to the confirmatory. So you can see the factor 1, factor 2. Why? Factor 1. What is my factor 1? What is my factor 1?
The first dimension.
Enablers.
Yeah, enablers. Okay. What is second dimension? What are the plus?
Barriers.
Barriers. I'm just adding the barriers. Okay. Barriers. Right. Now, I add the 2. So A1 to A6, it is called enabler. Right. B1 to B8 is barriers. Right. Now we can see this B1 to B8 is barriers. Right. Now I got the output. Right. I got the output very fastly. Right. Now we need to write the interpretation. One more thing you need to check. This is the p-value is talking about whether the model fit, whether you made this note. These are the two factors. These are the items are fitting. Now you can see this all the enablers. No, the p-value. All the p-values.
All are significant.
All are significant.
Barriers.
All are significant.
Then what is the meaning? This 6 items lies on the enabler. B1 to B8 is lies on the barrier. This is the way we are ensuring the what we ensure confirmatory.
Confirmatory.
This is called confirmatory because this are the item whether lies on the same domain. You got it? We are cross checking whether these are the items are contributing the same domain, lies on the same domain. Now it's contributing. Right. Now
So
we need to
just
cross
in
check
case-
some of the.
So just in case they are not significant, what shall we do?
Then that item is not. Then you are. What is that?
That
The
item
may
is to
not
be
contributed,
removed.
we can remove this item. That item is to be
Okay.
removed. For example, there's a B3
Okay.
items not be satisfied. Remove this item. I remove the B3. Right? I
Okay,
remove
sir.
the B3. So that's the way we can do this. Okay. This is called confirmatory factor analysis. So the problem we can see is the B3 comes last. Why? I'm just doing this because I added last no. Previously I deleted no. So I'm just once again doing this B1 to B8. So the same order. Then only the order may becomes right. Now, these are things we need to ensure whether the p-value is significant in the case of confirmatory. It seems that this item, this A1 to A6 lies on enablers in the enabler factors. In the case of B1 to B8 lies on the barrier factors. This is the way we need to ensure. And go to the additional output. We need to seek this additional fit measures. Otherwise, go with this KMO test, Paris, and AVE. And these are things you need to select. Okay. And now you can see this. We have the interpretations, the confirmatory factor analysis. I'm just showing these interpretations. These are the thumb rule. Don't be avoid this thumb rules and kindly take a screenshot. I'm just going to the confirmatory only. This was the confirmatory factor analysis. Yeah. Yes. Hope you are seeing this. The factor loading should be more than 0.5, but now you can see the sample size. Okay. Go with the AVE. AVE is for the measure the convergent validity. AVE score is above than 0.50. Right? Kindly check this AVE score. What is the AVE score?
Why p-value for A1 and B1 is not written?
Madam, this is the one, the first factor. Now, even you can see the path analysis you can get it. It will be loaded as one only always. Okay, it's loaded. Even path, and that's a good advantage. We can see this path also. Always the model plot. You can see this. I'm just clicking this. Show the parameter. Are you able to see the path analysis, path diagram? This path diagram you cannot get from the Jamovi. Are you able to see the path diagram?
Yes, sir.
And just interpreting this, going with this, interpreting the score also. You can maximize like this. Now it's visible. Now you can see this enabler. Enablers 1.00. That's always 1. And you can see this. I'm just interpreting how it's coming, the table and this one. Now you can see this A1 1.0, A2 1.15, 1.2. So kindly cross check the same things there. It's a loading. Right? Enabler 1.51, 1.2, 1.61, 1.51, 1.2. So because the diagram, I'm just going to make it properly. So we can modify it like this, okay? Right. So still you can, it will be minimum maximize. If you change the font style, it will be solved. So now we can see this, the enabler. You can see this, all the enablers. All the enablers is nothing but this loading only. According to this loading value should be, and showing this, the loading value should be, factor loading should be above 0.5.
0.50.
Then you can see this, all the factor loading is more than that.
Yes.
All
Yes,
the loading is okay, and p-value is significant, right? And one more thing, the diagram. What is this A1, A2, the score? It is called covariance
Error.
score. You can see the covariance. You can see the covariance table. Yeah, not covariance, like yeah, not this one. Yeah, this is the thing. A1 KMO test 0.567, 0.43. Not this one. Kindly see this, the model factor variance estimate is the score. Okay, I can enable the another 1 minute. So we have to select some more also. Enabler, model options, no need. Additional output, reliability, yeah, residual covariance. Select the residual covariance matrix also. So implied residual covariance matrix. Now we have the matrix. So each time the scores are may vary. Now A1 0.57. Now this is called residual variance. You can see this 0.57, 0.43. Where is, are you able to see this? This score is nothing but the point residual. 0.58, 0.47, 0.31. Where is the 0.31? This one. This is a table, residual varies. So now in the case of B3, 0.591, you can see this, the graph 0.591. Hope you are getting this. What is this one? 0.81. This is a relationship between enabler and barriers. Where is the relationship? The relationship, kindly find the relation between the barriers and enabler. We have the, yeah, the covariance. What is the scores? Estimate 0.8. Are you able to see the score?
Yes.
Yes.
So therefore, instead of writing the interpretation based on this table, kindly keep this diagram and write the interpretations, right? So it's very clearly highlighted. Always the first items, the loading should be 1. The first item loading might be 1 only, right? Suppose if you like to go with the unstandardized, go to standardized, then it changes. You can see the standardized. Now the scores may be changed. Are you able to see this? Because I'm running with unstandardized, but basically it's standardized. All the items are 5-point scale. All the item on A1 to
A6.
all the items are. Therefore, you can do the standardized. Therefore, this is standardized score. You got it. You can use the standardized. Even the almost also based on the context, we can use the standardized as well as unstandardized. You can write interpretation based on that. We can specify whether you can use the unstandardized or the standardized one. You can highlight this one. Suppose I'm going to standardized, I can remove this. And we can cross check some of the assumptions. The first one, chi-square test.
So your network issue is there.
Not okay.
Participants, please wait. I think there is a network issue with the sir's connections. We will intimate you.
Could anybody
Then,
explain?
yeah,
Sir is
sorry. I have the network issues. I can network issues. Hope I'm getting back. Okay.
Yes, sir.
Because my hotspot total lost. Okay. The total. Then I connected with the other one now. My voice is clear now.
Yes, sir.
Yes.
Yes, sir. So I'm taking 5 more minutes. Parthiban, please. Okay. So the factor loading, you can see this 0.5 above is acceptable. Then you can see this value of AV is 0.50 is also acceptable. And model fit RMSE is also less than 0.08 acceptable. Model fit CFA, this is called CFA. Comparative fit index, that's also above than 0.990 is acceptable. But one thing you must know this, when you cross check this JASP, the factor model, no, you can see this less than 3 chi-square value is better. So you can divide 235 divided by 76 is less than 3 or 5 is fine. It seems that the model is fit, even the model is significant, but you can cross check the 235.03 divided by 76 less than 3 or within the 5 should be there. Less chi-square test is needed for this. And the KMO score, the interpretation of KMO scores value should be more than, just showing the KMO score also. The KMO score interpretations, it will be more than 0.9, 0.7 is fine. KMO. Yeah, the KMO is 0.6 is acceptable, but 0.8 is good, 0.90 is excellent. So you can go with the 0.7 onwards. Okay, you can see this in this case, the item A1 is very less. All other items are very good. So 0.6 above only, except item, what is that? Even though it's satisfying the chi-square test, that don't worry about this.
P8 also, sir.
Yeah, this also less it seems. Yeah, P4 also.
P4 and B8.
And this is, yeah, and there is another one, dataset test. This is a course, practice test of sparsity. It's test where the variables are correlated. Enough for factor analysis. P less than 0.05 is significant. Now you can see this. It is significant. It is satisfied. It is satisfied. Okay, P less than 0.05 satisfied. So this way we can do a analysis, and all the diagram score, no, sorry, the table score, it comes to the diagram. So you can write the interpretation based on this. This will be better. You can keep the diagram, you can write the thumb rule, you can start write this. This for the confirmatory. Suppose I want to run this exploratory and I'm using the same data. I don't know theoretical model. Listen, confirmatory, you know that you have the two tables, factor 1, factor 2, then you done it. Once again, I'm showing the confirmatory, we have created two enabler barriers and we put it separately that model. But here, what I'm going to do, I'm just going to the factor, go to the exploratory factor analysis. Now I don't have any theoretical model. I'm keeping all the items attested here and variable. All the items I kept it in a exploratory. I don't know any classification because I don't know any model, but I want to run this manual because I felt that there's a two factors enough, right? From the old theory, you identify that the two theory is fine, or two factors fine. Keep the two factors. Otherwise, go with the eigenvalue. Eigenvalue is more than one is fine. If you go with more than eigenvalue one, we have the three factors coming. Are you able to see the three factors?
Yes.
Eigenvalue more than 3, we are getting more than 1, 3 factors emerge. Suppose I don't this, I want to keep it only 2 factors, keep the 2 factors. Now you can cross checks. The items are lying the same dimension. Are you able to see this? The factor 1, no. All the B's are coming the same factor 1. All the A's are lies on the same factor 2. You understood how the way is coming?
Yes, sir.
Actually, this is data for the confirmatory, but when you use it for the general also, it's lies are same. Therefore, this dimension, what is the name you can give this? The B2 to B4, no? This 8 items, what is the name we can give? That is called barriers.
Enabler.
The common priors are barriers. What is the name? Actually, in this case, we are defining the name based on the what is the category based on the characteristics of the items. So here we have here 6 items. The characteristics might be what is the characteristics? Enablers. We are defining this. You got it?
So
Now
just
we
in
have two.
case,
Sorry.
so just in case, like I'm working on AI, so I don't know what exactly. I just prepared
Then
question.
you can run this. Suppose it gave the 3 factors. For example, 3 factors. What you can do? Kindly cross check this item's basic characteristics. For example, item number B578268 Oh, sorry, B6. Kindly read this. What is the basic nature of this item? And make it a unique name for this. You can create name. For example, I'm just showing this confirmed meta analysis for my ML students. I done it for the research. I'm showing some model very fastly. That's all the exploratory we done it. I'm showing this my ML student dissertation for you. I'm just opening this. There is an one of my scholar. Mm. Yeah. Now you can see this is the SPS output. It is an SPS output. What it done it? Not it's like a exploratory only. It's not confirmatory. It's wrong. I'm just showing this. I think it's the wrong one. I'm going to the another one. The done it. Sure. Okay. Yes, you can see this. This is a tool for AI chat, but the same like what you done it the same way only. It's a AI tool, AI only. So we have the items. How many items? The items. It is Now extraction method. These are SPSS. There is an item number 35 items. When you go with this eigenvalue, how many factors are coming? 3 factors. Through the eigenvalues, 3 factors. That is a problem with SPS. It becomes different. And these are the items CP1, CP4, CP5. This much of items lies on the first factor. These are the items lies on second factor. These are the item lies on the third factor. So what it done it? So we need to compile the characteristics of this and just give the component one, a chatbot empowering education assistant as empowering education assistant. Second dimension, ethical and inclusive integration of a chatbot. Third component, optimizing the education through the a chatbot. You got it? So we define it and we are writing this interpretation based on this. So you can say this, these are the items are licensed in the same dimension. We are intended to measure the ethical inclusion of AI chatbots IT towards the education. And similarly, these items are lying on this factor, third factor. We are intended to reflect on this area. Like this, we can define this name. Hope you are getting this, Anisha. It's an exploratory factor analysis, right? So this way we can write here. Okay, exploratory. But good thing that for this model, it default is lies. Okay. Because I run it from the eigenvalue 3 factors, but I like to go with only 2 factors. What you can do, go to the manual, exactly comes 2 factors only. Are you able to see this 2 factor? And go to the oblique and go with the Fromax or Varimax rotations, okay, or oblique rotations. So when you go to the oblique rotation also, your factors are same only. Therefore, these are the items are the factor 1, dimension 1, these are the items are factor 2. You can write this interpretation. That's why exploratory. If you like to go with the same principal component, I'm just finishing principal component. Go to the principal component. Here also there is no factor. You can keep all together. All together. So here oblique, go with the Faramax, and we have oblique. You can go with the oblique. And once again, go with the eigenvalue. If you go with the eigen 3 factors, and go with the manual, if you go the 2 factors, you can see this principal component also. You can come the same. And go to the principal component number manual 2 factors. Are you able to see same 2 factors?
Yes.
Loading, all the B's are loading in a first factors. All the A's are lies on second factor. Then you can define this based on the characteristics called barrier. This is called enablers, right? So this way we can ensure it. And the good thing is that because the diagrams having a path diagram, you can see this is the path diagram. When you do the path diagram for this, path diagram, you can see this the difference between the arrow mark, these directions. Principal component analysis, the items are drive the factors. But you can go with the, I'm clicking this path analysis, output option path. Now you can see the diagram. Where's the diagram? Components are deciding items. You see this. This diagram, it is for the exploratory. This diagram for the PCA. And you can see this is the diagram. This is the diagram. Look like a structural equation modeling. This is here.
Confirmatory.
Confirmatory. I hope you're seeing the different diagrams. This is like a structural equation modeling. Same, right? How the enabler barriers. You can see the covariance, everything you can find out this. Right? But in the case of exploratory, the dimensions find these items, right? Based on the characteristics of the factors is identifying the items. But in the principal component, the items are designing a components, right? So this is only the difference between the confirmatory, exploratory, and PCA. So with this, we can stop this. If you want to do, if you have some doubts about factor analysis, sometimes some of things I not be highlighted.
Hello.
What you can do, once again, go to the open. Here we have a lot of data sets are available for the factor analysis. One by one, you can do this. The good thing that they are giving this interpretation also. Go with the G factor. when you go with this one, no, they're given how to solve also. So you can see this when you go to the solve, sorry, when you go to the this mode, data library, factors, and this one you can click like JASP file. You are getting this output also, right? And click the exploratory analysis. They will highlight which are things we need to enable and what is the line meaning. Everything they given some kind of description also. It will be useful, right? So thank you so much for your patient listening and active participations. Due to the time constraints, I'm not explaining much on this area. So if you want to text me, I will give this response on this. And special thanks to the three pillars of this particular program. They are my brothers only. One is our Cyril. He's a backbone, so he's a person flying, flyer designing and all. Then that entire program is organized by our Parthiban. So you know that the way he's connected with all the days and WhatsApp message. And the third is a very person, he's a very silent person. That is nothing but our, yeah, please, any questions? Yeah, there is a Venkatesh, that's a person also maybe contribute much. And special thanks to the two of the institution, one is for Thiyagu College, other one is Madurai Kamaraj University Center for Excellence. These are the two institutions also connected with this. Thank you so much to all the participants as well, the entire participants and the entire organizing committee. Yeah.
May I ask one doubt?
Sir?
Yeah,
Yeah,
please.
participants, you can pose your questions right now. And
Sir, if I have a data with the achievement test, which is subjective also and objective also, then what we should do for the item analysis?
Yeah, better in the case of subjective. Normally, achievement test is not possible to go with this Cronbach Alpha, and that's not be fair. Go with this one. Difficult index, discriminant index. Because how much the difficulty, the question, how much easy discriminant, that one you can check it.
Because sir, one question is of out of 10 marks, then
Yeah,
student only 5 marks, 4 marks.
That is not possible to go with the objective, because if we do a 1 mark question, we can easily to combine the scores and all. But for your case, you have a 10 mark question. There is a subjective is a question number. For example, you are giving a mark for out of 10, 8. How we can ensure it? That is the reason you can go with this internal, what is that? Internal, instead of evaluating by yourself, you can give one more person to evaluate. The two persons average you can take the consideration. And there is no right or wrong. If you can go with the discriminant index, we can check the right or wrong.